Welcome to Manifested Publishers. We offer CASNEP study materials and video lectures.
Hello everyone. My name is Mr. J.M. Kimani. I welcome you all to our sample paper 4 on game theory. This is the condition of competition. This is the environment of competition where the decision maker is not alone in the market and he has to consider other players in the market. That his action and other people's actions in the market will actually affect his outcome. In this case, when it comes to game theory, there are two main games. We have the zero-sum games and the non-zero-sum games. The zero-sum games are those games where the gains to one player are exactly the same as the losses to the player. In this case, one player, the loser, pays the other player, the winner. And the non-zero-sum games, being the games where the gains of one player are not necessarily equal to the loss of the other player, that the players may all gain, though gain differently, may all lose, or they may lose differently, or some players may gain and others losing. Now, zero-sum games, we may apply them in situations of betting, where one player pays the other in case you lose. And for the non-zero-sum games are games that we apply mostly for business. Now, the zero-sum games are also categorized into two parts. We have the pure strategy games, and we have the mixed strategy games. Pure strategy games are games where the players play a single strategy throughout the game. But mixed strategy games are where the players mix their strategies and they are going to achieve higher outcomes when they play a set of strategies. Then when it comes to zero-sum games, there are also two categories. We have the communicating games and the non-communicating or non-communication games. So these are the cooperative versus non-cooperative. The cooperative games is where the players are going to negotiate and agree on which strategies to play so that they can better their outcome. So therefore, their outcome is communal in nature. While the non-communication games or the non-cooperative games is where the players act on the individual rationality and therefore the decision is based on an individual. Those are now the two main games. Now, for us to understand this game theory, we are going to have two questions. The first question reads that two manufacturers compete in a market for a specialized calculator. Company A controls 75% of the market, while Company B controls 25% of the market. Company A is considering a vigorous annual marketing campaign, which will cost shilling 35 million. The total market for the specialized calculator is 100,000 units per year. The profit contribution per unit is shillings 3,000. Company B is debating how much money to invest in research and development every year. It is considering three alternatives: shillings 25 million, shillings 50 million, and shillings 80 million. It is estimated that if Company A runs a vigorous annual marketing campaign, its share of the market after 1 year will be either 79%, 75%, or 73%, depending on Company B's investment in research and development, that is 25 million, 50 million, and 80 million respectively. On the other hand, if Company A does not run the marketing campaign, Company B's share of the market will decrease by 1% of the total market. If it invests shillings 25 million in research and development, increase by 1% if it invests shillings 50 million in research and development, and increase by 3% if shillings 80 million is invested. Required. Roman 1. Using the share of the market percentages only, convert the above into zero-sum game and hence solve for the optimal strategies for both companies. Then Roman 2, obtain a payoff table consisting of contribution to profit in monetary terms and hence solve the game. End of question. Now this question has two parts. The first, Roman 1, is zero sum, and the second part is non-zero sum. Now for the zero sum, this is how we'll do it. So this is Roman 1, zero sum game. And then we are going to indicate there is now the payoff matrix. Payoff matrix. When you're indicating a payoff matrix for 2 by 2 or two person, that is two-person game, then we must indicate the one first player on the side, the other player up here with their respective strategies. For example, if you have to have here company B's strategies, which is shillings 25 million, shillings 50 million, and shillings 80 million in research and development. Then you have company A has either they conduct campaign or no campaign. No campaign. These are the two strategies for company A, campaign and then no campaign. Now we are going to have this way. This is company A. So campaign and then no campaign. The strategies are well laid, and then you have now the outcomes. We have been told in the paragraph that if company A runs a vigorous annual marketing campaign, its share of the market after 1 year will be either 79, 75 or 73. So 79%, 75% or 73%. And then we have been told down there that however, if company A does not run a vigorous market campaign, company B's share of the market will decrease. This is now company B, where currently they have 25%. We are told that it is going to decrease by 1%, increase by 1%, or increase by 3%. Now, remember, we have to be consistent and we have to be particular that we record for the company on the side here. So we cannot record for company B here. We record for company A, so be consistent. Therefore, as much as we are being given for company B, we need to translate this one and record for company A. Now, if company A has currently 75%, if company B loses 1%, that goes to company A. So company A is going to gain 1%. If company B gains 1%, that means company A will be losing 1% to company B. If company B will gain 3%, that means company A will lose the 3%. So what will be the new percentages? Now company A gaining 1% to 76, to 75, that will give us 76%. Company A losing 1% against from 75, this will give us 74. And company A losing 3% from 75%, that will give us 72%. 72%. And therefore, this being our matrix, we shall use what we call the maximin minimax approach, maximin minimax principle to solve for this game. And that means we look at the raw minimum as these items or these payoffs are gains to company A. So you look at the raw minimum. The minimum company A can make if they conduct a campaign is 73%. The minimum company A can make if they don't conduct any campaign is 72%. So the best is this one. For them, the best is this one, which we call it as the maxi mean value, the maximum that would have against them in the minimums. 73 is better. So they would rather choose this campaign strategy because the minimum they can make there is also high, is 73%, unlike the other one which the carries at 72%. Then we come to the column minimum, not minimum, sorry, but maximum, because of one thing. This is the argument. So we come to column maximum, because we are looking at the maximum company B is going to make. Remember, these are the gains to company A. They are the losses to company B. And therefore, the worst company B will make or we get is 79. That's the worst. The worst here is 75. And the worst here is 73%. That means, this being the worst company B is going to make, then the best one is this one, where we call it as the mini max value. That is the minimum of the maximums. You rather lose 73% than losing 75 and 79% respectively. Therefore, when the max-min and the min-max values they coincide, then we say there is a saddle point. And if they are generated from the same source, like in our case here, this we say is saddle point. Now, before I conclude, I hope you have understood about changing the information provided there for company B, gaining 1%, losing 1% and losing 1% and gaining 1% and 3% respectively. We have to change that one, convert it to company A, because we are recording here for company A, so that we can be consistent. So with that now, this is the end of this kind of a game that we are having a saddle point. So what's the conclusion? This is the conclusion and the first observation, that this is a pure strategy game, strategy zero-sum game. Why is it a pure strategy zero-sum game? Because each company is playing one strategy throughout the game. For example, company A will be campaigning, will conduct a campaign, that is, and company B will invest shillings 80 million, and that one is the strategy that we are going to indicate. These are the maximum and the optimal strategies. Then what is the value of the game? Now, value of game is where company A, when they are conducting campaign, they'll earn 73%, they control 73% of the market share, while company B here, as they invest shillings 80 M in R&D, they'll get 27% control of the market share. This will give us 100%. Now, these kind of games where the percentage is 100, we normally call them as constant sum games, because the total must be 100. Whichever we are going to select, total must be 100%. So this time, company A should be controlling 73%, while company B controls 27%, and that gives us 100%. That is all about that Roman 1, about the zero-sum games. Now, in Roman 2, we have been asked about to obtain a payoff matrix using the contributions. So this is how we are going to present it. This is a Roman 2. This is now non-zero-sum games, because as we present this one in terms of profits or contributions, every company will be making a contribution, and therefore we'll be having it as non-zero-sum. Now, the payoff matrix or the payoff table as we have been given there, this will be shillings in millions, because the amounts will be large. And we still have the same presentation, company A on the side, company B up here. So you have company B, we have shillings 25, shillings 50, and shillings 80. Then you have company A here. Company A, we have campaign, and you have no campaign. So you have campaign, and you have no campaign. Now let's look at this. We are going to do some calculations concerning the profit, and one thing to note is that our payoff, this is something to note, our payoff Our payoffs shall be the profits. And profit will be the contribution minus the cost. It can be the cost of campaigning or the cost of investing these amounts in research and development. Now, our total market contribution, this will be 100,000 calculators, each 3,000. This is going to be shillings 300 million. Such that if company A is controlling like 73%, then it means it is going to earn 73% of these 300 million. Company B is going to control 27% of these 300 million. Then now we have their respective cost. So like now if we were to have this kind of calculation, so company A, this is campaign. The strategy campaign. So company A are going to make or they're going to control in 3 ways, either 79, 75 or 73. So we're going to have here 79%, 75% and 73%, sorry, 73%. So of what? 300 million, 300 million, 300 million. Then you subtract the cost of a campaign, 35 million, 35 million, 35 million as presented in the question. So this is going to give us now the contributions as follows, or the profits as follows. This is 0.79 multiplied by 300 minus 35. This is 202. This is 0.75 times 300 minus 35. This is giving us 190. And this is 0.73 times 300 minus 35. This is giving us 184. That means I can record them here, 202, 190, and 184. Now I am leaving a space for company B because this time company A and company B will be making different profits, and therefore we must indicate a pair for each. Then we have company A. This is now no campaign strategy. No campaign strategy. So what will happen? Now company A, if you don't conduct any campaign, their payoffs are going to be 76%, 74% or 72%. So this way, so 76%, 74% or 72% of 300, 300, 300. So where we can subtract, there is no cost this time. There is no cost of campaigning, and therefore we'll just subtract 0 there. This will be 0.76 times 300. This gives us 228. This 0.74 times 300. This is giving us 222. And this is 0.72 times 300. This is giving us 216. So this will give us now 228, 222, and 216. That is all about the profits company A is going to make should they have these strategies, campaign and no campaign. What about if company B now would continue with their investment, either 25 or so? So we can have here company B shillings 25 M in R&D. If that we invest this money, then remember as we check in our payoff matrix, company A would control 79% as well as 76%. So in this case, if you are to actually calculate for company B, 79% means company B will control 21%. 76% means company B will control 24%, sorry, 24% of the market share, 24%. 300 minus the amount that money that we are spending is 25 million under this decision. So 24%. So what will happen? Let's see. 0.21 times 300 minus 25. This is giving us 38. And 0.24 times 300 minus 25. This is giving us 47. We come and indicate here 38 and then 47. Then we have company B investing shillings 50M in R&D, investing 50 million in R&D. Now, if you check in our zero-sum payoff matrix, where company A will make or will control 75% and 74%, company B shall be controlling 25% on the other hand, and 26% of 300, but this time this is 50 million to be spent. So this will give us 0.25 times 300 minus 50, giving us 25, and then 0.26 times 300 minus 50M, this is giving us 28. So we come and transfer here 25 and then 28. Then you have a company B, shillings 80 million in R&D. So investing 80 million in R&D. Now this will have, remember company A will be controlling 73% and 72%. So that means company B will be controlling 27% and then 28%. 300 minus, this time is 80 million. So we are going to have a very, very small profit there, if any. 0.27 times 300 minus 80 million, that is giving us 1M. And 0.28 times 300 minus 80, that is going to give us 4 million. We come and present here. This is 1 million and this is 4M. Now, having recorded all the possible or the profits that we may make depending with the investment, or either the campaign or no campaign, and the investment company B will make. So we can make a conclusion that it will not be possible for us to select a haphazard, because remember, it's a constant sum game. There is no way you can choose, like for company A, selling or controlling 79%, while company B, maybe they are controlling like say 28%. Because if you do that, the percentage in total will give us like a 107%, which is already more than 100%. It's not possible for you to have a total sale of 107%, which is exceeding the market. So in this case, we are going to make some concession here, that we must select a pair that adds up to 100%. This pair adds up to 100%, 100%, 100%, 100, 100, and 100. So you're going to choose the pair that is going to be favorable for all the players. And the only pair that is going to be favorable for all the players is this pair. This is the pair that is going to suit all the companies, because company A earning to 228 million is going to be the best compared to others. Company B earning 47 million is going to be the best for all the companies, and for the company B, sorry, among or comparing with all the rest. Therefore, this is the best. And therefore, what is our conclusion? This is going to be our conclusion, that the optimal strategies is where company A will have no campaign, will not conduct any vigorous campaign, and company B will invest shillings 25 million in R&D. Now with this, what is the value of the game? So therefore, value of game shall be company A 228 million, company B making 47 million. This, when you add, will give us 275 million, being the highest. And that is the best you can make when you make a comparison of all this. Now, this means we have concluded the question. We have come to the end of that question because we have found the best, and this is the best pair as you compare with the rest. And we have found that the optimal strategies is where company A does not conduct a vigorous market campaign, as company B, on the other hand, invests only 25 million in the research and development, and the value of game is 275 million in total. Otherwise, as a zero-sum game, we found out that company A should campaign and company B should invest in 80 million in R&D. But when it comes to the amounts, then the game changes, and that is how. So that question is over about the zero sum and the non-zero sum, and that is all. And you have indicated and you have done everything. So I would urge you, you still revisit the same question, look at it, understand all what I've explained, follow what are my explanations and all that I've done, and that would give us the positive understanding. That's all about the question. So the second and the last question that is going to make us understand majorly on the zero-sum game, and especially the questions, the games which are not pure. Remember, this one was a pure strategy game. We can have a second question, a question that does not have a zero-sum game. Maybe, no, it does not have a pure strategy game, but maybe a mixed strategy game. Now, the question reads that Topcom Kenya International Limited is a telecommunication company situated in Nakuru. Recently, the company was faced with a workers' strike, which necessitated a negotiation of the workers' salaries through their union. The management, with the help of a consultant, has prepared the payoff matrix shown below. There is a payoff matrix, workers' union strategies. We have U1, U2, U3, and U4. And you have the company strategies C1, C2, C3, and C4. Then the payoffs are written, indicated there. I'm going to read them across. Positive or plus 2.5, plus 2.7, plus 3.5, and negative 0.2 across respectively. The next one is positive 2.0, positive 1.1, positive 0.8, and positive 0.8 across respectively. The third one is positive 1.4, positive 1.2, positive 1.5, and positive 1.3 across respectively. And the last one is positive 3.0, positive 1.0, 1.9 positive, and 0 across respectively. A positive sign represents a wage increase, while a negative sign represents a wage decrease. Required, Roman 1, advise the management on the best strategies, and Roman 2, the value of the game. End of the question. Now, this will still set it just like this question. Then we are going to apply the row minimum and column maximum using the maximin and the minimax approach as follows. So we're going to have this way. So still zero sum in Roman 1 on this question, and we look at it from that perspective. So we're going to have this way. In the payoff matrix here, we have the workers. This is union. Let's say union strategies. We have U1, U2, U3, and U4. This is U2. And then we have the company. This is company. It has C1, C2, C3, and C4. So I'm going to avoid the positive sign, as a figure which is positive will mean it is a gain. Now this is a 2.5, 2.7, 3.5 minus 0.2. This is 2.0, 1.1, 0.8, and 0.8. This is 1.4, 1.2, 1.5, and 1.3. And then you have this is 3.0, 1.0, 1.9, and 0. So this is what you have. Now this is the matrix that you have been given. We have been told that the positive means a wage increase, and therefore this presentation would be different from what we have been doing because remember, the positives normally are the gains to this player. But for this one of ours this time, the positives are the losses of this company. Therefore, we are going to interchange. Either we can do two things. We do opposite of what we have been doing, like if it's the row minimum, this time we do the row maximum. Instead of the column maximum, we do this time the column minimum. Or else you transpose. Transpose means like you have the union here and the company up here. And then now the positives will now be for the union, and therefore now will be no more payoff, and we proceed with the solution. But it's good also to be flexible a bit, not to have only one set of maybe approach. We can try to expand our knowledge and exposure. So let's do it the way it is. We do the opposite. So instead of us now looking at the row minimum, we do row maximum, because the argument should be the same, that we are looking at the worst scenario. Now, the worst of the company is when they are awarding a very high wage increase, the worst. So the worst here is when they are awarding 3.5. Here is when they are awarding 2.0. Here is when they are awarding 1.5. And here when they are awarding 3.0, that is their worst. And therefore, they would rather award 1.5. And this is now what you can call max value. The minimum of the maximum. That's the minimax. Then we come to the union. Union, they are benefiting when they are when there's a positive. They are benefiting. So their worst is the negatives, or either the worst is the smallest positive. So that's why I'm recording here column minimum. The worst that the union can get is an increment of 1.4. The worst here is an increment of 1.0. The worst is an increment of 0.8. And the worst is even a decrease of 0.2. These are the worst. Now, this being our best, these are positives are as earning. So we would rather settle on the one that is giving us somehow a higher percent increase, which is this one. So this now is what we can call maxi mean value. Maxi mean value. That means what? The maximum of the minimums. Now, when the maximin and the minimax value are the same, there is always a saddle point. But for this one, no saddle point. So we're going to have here NB, no saddle point. Therefore, dominate or reduce the game to a 2x2 matrix, or step by step. What I mean by step, I mean you can reduce the game. This being a 4x4, you can reduce first of all to a 3x3, then you reduce to a 2x2, but ultimately you are going to reduce to a 2x2 as the maximum. But if you can reduce to a 3x3 and you end up getting the game, the value of the game, well and good. But if you do not again get the solution, or you don't get the saddle point, after reducing to a 3x3, you have to again reduce to a 2x2, which is now the end of dominance. That if you do not get the saddle point again, now it's not going to be a pure strategy, but a mixed strategy. So I'm going to take the approach of a 2x2 direct. That I'm going to eliminate the 2 rows and 2 columns, because the 4x4, I eliminate the 2 rows and 2 columns, I get by 2x2. Now remember, we normally say that you're going to eliminate those columns and those rows, or those strategies that are the worst. So this means eliminate strategy worst. Let's say eliminate worst strategies. Eliminate worst strategies. Now I'm avoiding indicating exactly what I indicated when I was doing lessons, because when I was doing lessons, I indicated that I eliminate the row with the minimum values, the columns with the maximum values. I am avoiding that because this time our matrix is different, that we are having now the positives being the loss on the player for the player on the side. Therefore, I don't want to indicate that. I want to have some understanding, eliminate the worst strategies. If it is a company, we need to understand the worst strategies of that company is when they are giving highest or a lot of salary increment. The worst of union is when they are receiving very small salary increments, and therefore that is it. Another thing to note is that we can use either observation or summation. What I mean by this is you just observe and look at the worst row or the worst column of these players, and if that become tricky, then we need to sum. We sum up, we add across and downwards, and then we eliminate now the one that is we consider a worst. So let me just use the second one, this summation, because it is going to be clear to everyone when you do summation, unlike the observation. But observation again is useful if the summation tie. If we sum up and we end up having a tie in our summation, then the observation comes in to unbreak these tie. So you can have this way now. This is U1, U2, U3, U4. This is C1, C2, C3, C4. So we have 2.5, 2.7, 3.5 minus 0.2. We have 2.0, 1.1, 0.8, and 0.8. We have 1.4, 1.2, 1.5, and 1.3. And this is 3.0, 1.0, 1.9, and 0. So we are going to use the summation. So we sum up row-wise and also column-wise. So for example, as we sum up these row-wise and column-wise, we indicate we are going to have these kind of calculations. So this is 2.5 plus 2.7 plus 3.5 minus 0.2, giving us 8.5. We have 2 plus 1.1 plus 0.8 plus 0.8. This is giving us 4.7. Then you have 1.4 plus 1.2 plus 1.5 plus 1.3. This is 5.4. Then you have 3 plus 1 plus 1.9. This is giving us 5.9. Then when you add downwards, we do have 2.5 plus 2 plus 1.4 plus 3. This gives us 8.9. Then you have 2.7 plus 1.1 plus 1.2 plus 1. This is 6.0. Then you have 3.5 plus 0.8 plus 1.4 1.5 sorry plus 1.9. This is giving us 7.7. 7.7. And the last one is a minus 0.2 plus a 0.8 plus a 1.3. That will give us a 1.9. Now, we reason this way. The company is going to lose so much when they are to give a total of maybe the highest, which is 8.5. This is going to give or expose the company a lot, and therefore would want to eliminate it. This is what the company should eliminate because it is exposing it higher than the rest. Followed by this one of 5.9. So this one C4 will be eliminated because it's exposed the company a lot, 5.9. So we'd rather have the company maintaining a 4.7 and a 5.4. That is better, is manageable than compared to the rest. Then when it comes to the union, this is what the union are going to get in total. They should eliminate the one that is giving them the least increment, which is this one. U4 is giving us the least, well followed by this one, U2. this is giving the company or the union the least increment. They would rather maintain the 8.9 and the 7.7. So with this now we can have our conclusion here that we are having U1 and U3. This is a C2 and C3. So this is going to be our 2 by 2 matrix. This is a 2.0, and then you have a 0.8. This is a 1.4, and you have a 1.5. So still we do the same thing. We look at the row maximum and the column minimum in this scenario. So the maximum, the company would lose highest 2.0, and here will lose 1.5. This is better. They better lose 1.5 than losing 2.2. This is now the minimax value, minimum of the maximum. Then the union, they are going to lose if they get 1.4 and if they get 0.8. They are going to lose these. They better actually, when the minimum of 1.4 is better because it is a positive for them, they are going to make a 1.4 salary increment. So this is now what you can call a maxi mean, a maximum. So maximum of the minimum, so maximum value. Again, being a 2 by 2, there is no saddle point. So what we conclude is that at NB, no saddle point. Therefore, this is not a pure strategy game, but a mixed strategy game. This is not a pure strategy game, but a mixed strategy game. That is how we are going to play it. Now, what do we do? It means we are going to solve this as a mixed strategy game as follows. This is solution solving a mixed strategy game. Solving a mixed strategy game. So we are going to have the first approach is the what you call algebra method, where we normally look for the probabilities or the proportion of the union playing U1 and U3 and the company playing C1, C2 and C3. So we normally indicate this way. So we can have the union having their probability as Q and 1 minus Q, the company having their probability as P and then 1 minus P. We are just substituting the strategies with unknown values or unknown variables. So this is still 2, 1.8, and you have 1.4 and 1.5. So this is how we play the game. We set equations this way, that if this is now the company playing. Now company A, remember they are going to play both strategies in this proportion of P and 1 minus P. So that now when the union plays the first strategy, company A will have this is 2 2P plus 1.4 in bracket 1 minus P. Then the result should equal to when now the union is playing the second strategy. So we must make sure that this result is equal to this one. And by the way, this one is not 1.8 from our transfer here. If you check well, this one was 0.8, but not 1.8. Sorry for that. This is 0.8, but not 1.8. Now, let's indicate that this is the result. So this is going to be 0.8 P plus 1.5, 1 minus P. So this is going to give us 2P plus 1.4 minus 1.4P equals to 0.8P plus 1.5 minus 1.5P. So like terms together, this is 0.6P plus 1.4 equals to this is 1.5. Then we'll be having a minus 0.7 p, because if you are to have this is 0.8 minus minus 1.5, the answer will be minus 0.7 p. So like terms together, if you are to transfer this p this side, this will be 1.3 p equals to, this will be 0.1. So therefore our p shall be 0.1 divided by 1.3. This will give us, so 0.1 divided by 1.3. This is 0.07, 0.08, let me say 0.08. So that now the 1 minus p can be 1 minus 0.08, which is 0.92. So that means that the company is likely to play more the second strategy, which is C3. C3 is what the company likely to play compared to when they are playing the first strategy. Then the same thing happens to the company, the union here. So you're going to have the union playing. This is union playing. When they play, we'll have this happening, that they will be having the 2q plus, so 2q plus 0.81 minus q. They are going to make sure that that outcome when the when the company is playing p is the same as this one, and therefore we are going to have 1.4 q plus 1.5 1 minus q. So in this case, it means this is a 2q plus 0.8 minus 0.8 q equals to 1.4 q plus 1.5 minus 1.5 q. So that now we can have like terms together, 2q minus 0.8. That one is 1.2 q plus 0.8 equals to, this is 1.5 minus 0.1 q. So like terms together, if I transfer these 0.1, this side will be 1.3 q equals to, this will be 0.7. So that therefore now q will be 0.7 divided by 1.3. This shall give us 0.7 divided by 1.3. This is giving us a 0.54, and therefore 1 minus q shall give us 0.46. Now therefore, to make a conclusion, therefore, it means if we are going to have this way, so q is 0.54 and this is 0.46, while this one p is 0.08 and we have 0.92. So we are going to have this as our conclusion. So we had 2, we had 0.8, we had 1.4, and we had the 1.5. So in this case now, our value of game, this one of course is what we call the probability. This is like Roman 2 here, probability method. So this we are going to say the value of game. So value of game will be expressed value of game equals to summation of x I j p I, meaning that we take the payoff, we multiply by the respective probabilities. So probability for company and probability for the union. So in this case, we are going to say that this is 2 in bracket 0.08 times 0.54, then plus 0.8 in bracket 0.08 times 0.46, then plus 1.4 in bracket 0.92 multiplied by 0.54, then plus 1.5 in bracket 0.92 times 0.46. So this will give us, let's indicate, so this is 2 times 0.08 times 0.54 plus 0.8 times 0.08 times 0.54. 0.46 plus 1.4 times 0.92 times 0.54 plus 1.5 times 0.92 times 0.546, that is. This is giving us 1.45. Now, what is the conclusion? The conclusion is that the management are going to lose 1.45%, or in this case, the union is going to attract. So you can see here that therefore, the company shall pay 1.45% wage increase to the workers. So the company shall pay 1.45% wage increase to the workers. That would be our conclusion. Now, the most important thing here is to know the procedures, as we have started from there, determining whether this is a pure strategy game or it is a non-pure, which is a mixed strategy game. And therefore, we have found out that we didn't have the saddle point in the first instance. Even after dominance, we didn't have the saddle point, and therefore we concluded that this one is actually a mixed strategy game. Then from there, we solved for mixed strategy game using the algebra method and also the probability method. Algebra method is to give you the optimal strategies for each player, while the probability method is to give you the value of the game. So we have able to conclude that yes, the union and the company are going to play these two strategies, and then they are going to have the value of game being 1.45, meaning that the union is going to maybe gain, as well as the company is going to lose to them, is going to pay them 1.45. That is all about sample paper 4 about the game theory. For now, that is all about the revision concerning decision theory and especially the game theory. So I wish you all the best as you make more revision and more understanding, and as you make reference to what I've done, both in the revision as well as in the lessons. Thank you from me. All the best.